Hello, and welcome to your OPS 345 Lecture 3, where we're going to talk about Lab 2. Now, this week in Lab 2, just like last week's video, I'm going to kind of go over some theory for a little bit, and then we'll actually look at the stuff, right? So this week in Lab 2, you're going to set up some basic Amazon or AWS networking. And don't let that fool you. Some of the stuff we're doing is pretty complex because it's being done in the cloud. We're taking like basic networking concepts and we're applying them to the cloud. You're going to install an instance and configure it to act as a router in the cloud using port forwarding through IP tables. If this sounds a little too complex, don't worry, we're going to get there. You're then going to forward all the incoming traffic, inbound SSH anyway, from the router to the other instances that we're going to configure later. And in fact, we're actually going to configure another instance today, but we're going to rebuild it next week. The router is going to stay as it is today, and that's where like the most of the stuff is. But the other instance that we build today, we're going to rebuild next week. So don't worry about that one too much. And we're going to talk about that more in a little bit. But first, before we get into anything, we need to look at a few other cloud concepts, and specifically AWS's implementation of them. And then we'll get back to IP tables. So first up, we have some new things that we're looking at this week. One of those is VPC, which stands for Virtual Private Cloud. And this is an AWS specific thing. But other clouds implement things similar to this, just in a different way, and they call them different stuff, right? I told you I'm going to try to stick to like generalized cloud concepts, but sometimes we're going to have to look at like specifically how this one thing works in AWS specifically, because we're working with AWS. That's just the way it is. Now, the whole general idea and the I guess advantage could call it. The way that people use the cloud and implement the cloud, the way businesses use the cloud, is that your servers and your services aren't necessarily physically located on site, right, at your office, at a building that your company owns. You don't have your own data center per se, unless, of course, you're using a private cloud. But we're looking at public cloud right now because that's what we're using, right? We've talked about private cloud in the past. Now, where do those exist? Well, it doesn't really matter, right? You're paying a cloud provider to do that. So you usually host these sources wherever you can get them the cheapest, right? Because you want to save money. You're paying, but you want to spend as little as possible. Now, cloud providers have the advantage that that they have this infrastructure that they've built, so they can use what's called an economy of scale. Gives them greater flexibility for resource management. And they're doing this as a service, right? They're doing this to make money. You have to always keep that in mind. So when you're not using a particular component, somebody else is going to pay to use it. So the hardware's not sitting there idle. It's not getting old. It's not wasting electricity. It's not just sitting there waiting for you to do stuff. It's in use by somebody else if you're not using it. That's the way it works. So VPC, I already mentioned, stands for Virtual Private Cloud. And that means that the resources in it that you're using are not dedicated specifically to you. But they are allocated to you and secured, like segregated, through software configuration implementation, right? So the stuff in your Virtual Private Cloud exists somewhere, and the resources that you're using, the physical resources, might be used by someone else, might be not. Like they will be used by someone else when you're not using them. And you're not necessarily going to have the exact same physical resources every time you boot up. Everything's sort of obscured through software. And for most things, like that's secure enough, right? Now inside your private cloud that you've created in a public cloud using your virtual private cloud, which is like, don't let that confuse you, right? We're not talking about private cloud in the context that we've used private cloud, right? We're using a virtual private cloud within a public cloud. AWS is a public cloud provider. So like it's somewhat private, but AWS still has full control over everything. So it's not really private. Does that make sense? I think that makes sense. Anyway, inside this virtual private cloud, you can build whatever you want. You can have networks, file storage, compute power, so that's VMs or instances for doing things, right, for servers. You can have databases. Remember that like those are all separate things in the cloud, right? The advantage of the cloud is as a service. So you can do things like database as a service, right? So it's available for your entire cloud instance without requiring, or I used instance in a way that I shouldn't have used it there. It's available for your entire cloud implementation, not necessarily running on an individual instance or VM. See, I caught myself, but like that's a word I gotta watch because that means a specific thing, right? Accessing all of these resources is available through what's called an internet gateway, and this does port forwarding. And it's even used if your VMs have a public IP address. You can't get to them. You have to go through the internet gateway. So this is like a little bit of security, right? It makes it a little more secure to do stuff. If your software uses any resources from outside your AWS virtual private cloud, those also connect to your virtual private cloud through that internet gateway. Does that make sense so far? I hope that makes sense. I think it makes sense. Makes sense to me. And of course, if it doesn't make sense, write the question down. Bring it to class. That's the advantage of doing this as a video, right? Now, before getting into this course, you're a semester 3 student, you should have learned a little bit about IP addresses and subnetting. And you've heard that term and you're probably thinking, oh my god, we're not going to do subnetting in this course, are we? Well, we have to. It's a networking course, right? But it's going to be somewhat simple subnetting. It's not going to be too difficult. If you're not like an expert at subnetting, don't worry. You don't have to be for this course. But the two things that we need to kind of pull from that networking stream of courses and we're going to use in this course are your private IP ranges, your private subnets, and we're going to actually create our own private subnet. Now your VPC, your virtual private cloud, can have any number of private subnets you want. There's no limit, as long as they fit in the allocated private subnet ranges. So that's your 10.0.0.0 network, right? Your 172.16.0.0 network, if you're using the class B, and the 192.168.0.0 network if you're using the class C. We're going to use the class A, the 10.0.0, but we're going to use it as a /16. Normally you see that as a /8, right? We're going to use it as a /16. And we're going to use that to make two smaller subnets. So your VMs are going to be in 10.3.45.0/24. 25, sorry, not 24. So that means we're borrowing one bit, we're dividing that address space into two smaller subnets. Makes sense so far? The machines in your subnet can automatically connect to each other, but they do not have access to the internet automatically. They need an internet gateway and a public IP, right? 10.3.45.0 is not publicly routable on the internet. That's the drawback to using those private ranges. And we're going to look at that a little bit more later. I think I talk about it a bit later. Because it's kind of a security reason we're doing this too. Right. So, AWS, we're going to look at public IPs now, right? We talked about private. We're going to look at public. AWS automatically assigns a public IP to your VMs from its pool of addresses. AWS has their own public addressing space that they've divided up and subnetted and done whatever with. They own that, and you're paying to use that, right? They're dynamically allocated, and every time you shut down your VM, you get a new public IP. That's not great for a server, right? We want a static IP, not a dynamic IP. And what makes this a little bit weirder is if you actually look at the VMs that you've created, the instances, the public IP isn't actually configured as an IP on that interface. It's assigned instead to your VPC, your virtual private cloud. See how we went back there? We're tying it all together. We're slowly building on the stuff. So all incoming connections are then port forwarded to the VM to which you assign the IP to. It's a weird implementation. It's very different from what you've seen in previous courses and really what you see anywhere else, right? It's kind of bizarre. And that's going to be part of the challenge for some of the stuff that we're doing. But this sort of port forwarding, this exists. You've already sort of seen this in action. This is how your home router works, right? You have a single public IP address on your router. Well, your modem or router, whatever, has that. And then internally on your network, you're using the 192.168.something.something subnet, right? You've got private addresses. And they are all dynamically mapped using NAT, Network Address Translation. Your router does all that, right? This is the same idea. It's just in the cloud, and we're using an internet gateway to do it. That's it. It's not too bad, right? So on to static IPs, because we're looking at those, right? For those private IP address ranges, right? The 10.0.0, the 172.16.0.0, and the 192.168.0.0. Those don't cost any money. Anybody can use those totally for free. So they're static by default, in AWS anyway. Now, AWS does have a DHCP system where you can reserve a static IP address from your private pool for your VM. And if you do that, the VM will automatically get that static IP from an AWS configured DHCP server. If you don't, the VM's going to get an unused IP from the same subnet, and it will use that dynamic IP every single time it reboots. So that's kind of handy, right? But you can also assign a static public IP address to your VM or your instance. And you could use your own, but, well, you don't own any, right? So we're going to use an elastic IP. That's what AWS calls it. This comes from AWS's dynamic pool of public IPs. But you're going to reserve that for your use. So that is going to be your IP address. Now, the interesting thing about elastic IPs is they're free when you use them, but they cost money if you don't use them. So when you're not using this, it's going to be costing you money. It's going to be coming out of that $100 credit that you get. This is one of those things that uses that, right? And that's because there's a limited pool of public IPv4 addresses. And in fact, like, we ran out globally a long time ago. So once you request one of these addresses, nobody else uses it. So you need to use it, right? Or you're going to have to pay to keep other people from using it. Now, your VMs, they're going to be down most of the time. Your instances are going to be down most of the time. So this is one of those things that's coming out of that $100 credit, just kind of across the board as a heads up. Does that make sense? So that's like a whole bunch of networking that we just looked at, right? Well, now we're going to go back and talk about the firewall. That, well, we started with that, right? We're doing some stuff with IP tables this week, which is a firewall. So IP tables you should have used in OPS 245. And if you didn't fully grasp the concept there, don't worry too much. IP tables is one of those things that people struggle with. I myself struggle with IP tables. It takes a while. We're going to give you some stuff that you need to know here, and it's not horrible. But we're going to continue to expand. We're going to build on what you learned in OPS 245, and I'm going to give you a little bit of review on that. But before we get to that, let's look at some useful or interesting things that you may want to know, because they're interesting about different firewalls and the evolution. So we're using IP tables, and that's a firewall that's available in Linux. My screen just timed out. Just going to log back in. Don't know why, just am. IP tables is a firewall in Linux, and it's one of the most commonly used ones. It's not the only one, and it's not the newest one. IP tables have been around a long time. It's been around since 1998. And we'll get to why it's the one that's most commonly used, but we're going to look at some other ones that have come out since that are a bit newer. First up is Firewall D. It's firewall, and the D is short for daemon, like most services. That's what they called it. It's another firewall. We're not using it in this course. We're going to use IP tables, but Firewall D is newer. It released in 2011. That may sound pretty old, but it's not that old comparative, right? IP tables have been around since 1998. Firewall D syntax is a bit more complicated than IP tables, and that's one of the reasons why it's not used as much in industry. And then we get NF tables, and that's yet another firewall, which we'll also not be using in this course. And it's even newer than Firewall D and IP tables. It came out in 2014. Its syntax is a little cleaner, but it's longer. It's a lot more closer to human sentences to describe the configuration that you're doing in the config. And with all of these firewalls that we're talking about, we talked about IP tables, which you've used, Firewall D and NF tables, which you may or may not have used, but are around. You're probably asking yourself, why is IP tables one of the most commonly used ones? Well, the short answer is businesses don't like to change, because change takes time, and that costs money. And I'm sure you've heard the old adage, if it's not broke, don't fix it, right? If it's working, why are we going to, and there's no noticeable improvement, why are we going to pay money to change all our configuration, right? This is why bank machines use horribly out of date operating systems. And in fact, up until a couple of years ago, bank machines ran Windows XP, which is crazy, right? But that's the way it works. So we're going to use IP tables in this course because it's one of the most commonly used ones in industry. And you don't have to be an expert with IP tables, but I'm not an expert in IP tables, right? This is one of those things that I mentioned in an earlier lecture. When I first taught OPS 335, the predecessor to this course, many years ago now, 8 years ago, I asked a friend of mine who works in industry as a Linux admin, how good are you with IP tables? Because I felt a little not as confident in my IP table skills. And his answer was, as good as Google lets me be. And I thought, well, shit, if he's got a full-time job in industry and that's good enough for him, that's good enough for me too, right? And that's good enough for you. You don't have to be an expert, but you have to know the basics and be able to kind of figure it out. So IP tables consists of the following which we used in OPS 245. The input chain, which applies to inbound packets on the machine or VM or instance that it's configured on, right? It's from that perspective. The forward chain, which applies to traffic passing through the machine. And the output chain, which applies to traffic leaving the machine or VM or instance, whatever you want to call it. Now, you should have learned about these three chains in OPS 245, and you should have used them there. And that's a predecessor to this, or a requirement, right? A prerequisite for this course. So I know you've taken it. Doesn't matter if you got an A or not. You've been exposed to this, presumably, right? This week, we're going to look at a couple other chains that you may or may not be as familiar with. Specifically, we're going to look at the pre-routing chain and the post-routing chain. Now, the pre-routing chain applies to packets that have been received, but before any routing decisions have been made. So the VM or instance or machine doesn't even look at the contents of the packet. It never hits the input, forward, or output tables or chains within IP tables. It goes to pre-routing, it gets processed, and if there's a rule, boom, it goes. And that's it. Post-routing applies to the packets that are leaving the machine after a decision has been made on where to route the packet to. The packet is then passed to the hardware for processing. And at this point, you're probably thinking to yourself, well, sir, we've learned all about configuring security groups. So why do we need to configure a firewall on our servers? Well, the answer is layers, right? Think back to what I said about previously about security. Security is like an onion, or like an ogre. It has layers. In AWS, security groups, the security groups that we've configured, and we're going to configure a new one today, are our first line of our defense, our first layer. Well, what happens if that one is breached, right? We need another line of defense. We need another layer. If you're thinking like a castle in siege, we need another wall. That's our firewall. So configuring IP tables on your server adds another line of defense. Or, if we relate back to the onion/ogre analogy, another layer. Now we're going to take this even one step further. We're going to configure a new instance today, and we're going to call it router. And that instance is going to route traffic to and from our internal network through port forwarding. In fact, next week when we're going to configure a new instance, and it's not even going to have a public IP address associated with it. All of the traffic to and from that VM or that instance is going to be forwarded there and back through our router, which is pretty cool. Now this is pretty common. It's a pretty common security method employed in industry, whether it's done the way that we're doing it or not. You might have, with a physical configuration, you might have a Cisco router that's configured to use NAT, which you should be familiar with, but is network address translation, to translate some public IPs to the private IPs that have been configured on your servers. So your servers are not directly publicly accessible. The traffic has to go through your router. Your home router works exactly this way, only NAT is providing a binding from one public IP, to many private IPs with your home router. Instead of that, you're going to configure a one-to-one. So that's one public IP to one private IP. So if you've got multiple servers, you would have multiple public IPs. We're not going to do it that way. We're just going to have one public IP, and that's going to be bound to our router VM, and all of the traffic is going to be forwarded internally in our network through that router VM. So this adds another layer of obscurity to your network. It makes it a little more difficult for the attacker, if they're trying to break in, to figure out what the big picture of your internal network really is. Does that make sense? I hope that makes sense. All right. So I was planning on leading into this next section with something like, with all that in mind, let's start Lab 2, shall we? However, if you happen to pay attention to the clock at the bottom of the window, you'll notice that I hit pause in my recording about 6 hours ago. And I honestly can't remember exactly where I left off. But I was going to lead into Lab 2, so I paused. I know where I paused in my notes. And that's fine. Just kind of trying to collect my thoughts and think about what I was thinking 6 hours ago. And a lot has happened in between. There's a reason I had to pause. Life got in the way. As I know it does sometimes, for not just me, but all of you as well. Before we get into Lab 2, I do want to make a quick mention of your Quiz 1, which is going to be next week. I can provide you more details in the lab. I currently have not written Quiz 1 yet, but I know roughly what I want to do. I'm currently thinking 5 multiple choice questions per week of content that it is going to cover. And since Quiz 1 is going to be in week 4, we're going to cover 3 weeks worth of content. So 15 questions, probably all multiple choice. I will update you in the lab if that all changes between now and then. And I'll post an announcement for anyone who isn't coming to the in-person lab sessions for whatever reason. Maybe you don't feel comfortable being in person. I totally respect that. If that's why you're not coming, then that's fine. Although, troubleshooting problems is a lot faster in the lab, right? So, you should be there. There's definitely a benefit to it. There's a whole reason that we're back in person for some things. Now, something else I wanted to point out very quickly, because I stumbled across this earlier, and it might make your life a lot easier. I know it's going to make my life a lot easier. Because one of the things I struggle with personally is trying to remember in which screen, in which little thing this is. That's part of the reason that, I don't like Windows Server on a server, and I prefer Linux. Because just give me a command line and I'll figure it out. I'm good to go. But if you ask me, which tab in which screen, in which, I have to go through, 6 different menus to get somewhere, I'm not going to remember. I'm going to write it down somewhere, so I can do it every time. And that's a good technique to overcome, like I know that's a personal weakness of mine, that's a good technique to overcome that. Write stuff down. However, if we click the services all here, and we're going to run some stuff in Lab 2, and you find something that you think you might launch a lot, like for example EC2. Well, you'll notice it's recently visited here, and yours probably has a, if you hover over it, a grayed out star. If you click that star and fill it in, it'll add it to your favorites, which means it also shows up right here. Really handy, isn't it? So now to get to EC2, I just have to click there. I can do things a little faster. It's finding those little shortcuts. That's going to be very, very useful. And I think that's going to be very useful going forwards in the labs. So let me pause for a second, get something to drink, and we're gonna get into the first part of Lab 2. So we talked about a lot of networking components, right? We talked about VPCs, we talked about IP tables, we talked about public and private IPs and static IPs and subnets and like all kinds of crazy stuff, right? We're going to actually do some stuff now. We're going to create our own VPC, our own virtual private cloud in AWS. And you're going to see that I've pinned it here. I've added it to my favorites because I think this is something we're going to use a couple times at least. I know for me it's going to be something I've used a couple times because I've already done this once, so that should make our run through here a little bit cleaner. And you're going to see some stuff in my configuration that you don't have because, again, I've already done this once and I made notes. That's how my videos are good. I've mentioned this before. So it says for creating VPCs, it says click your VPCs. Note there is a default one there that was automatically created with your account, and click create VPC. Well, if I didn't have this pinned here, where the hell do you go to get there? Right? So if we go to services, and we go to hold on a second, I gotta consult my notes because I made notes on this. All services, networking and content delivery. And I just kind of guessed to get there the first time because I was like, where the hell is this VPC thing? I don't see it. Look at that. It's right there. Oh, and look, see, you can favorite things right here too. That's great. So click on VPC right there. So networking and content delivery under all services, VPC management console. And give it a minute. It might take a minute to load. So we see a whole bunch of crap here. Well, it says click your VPCs. That's over on the side here, right? So we see your VPCs. In fact, a few things we're going to use. Subnets, route tables, internet gateways, elastic IPs I think we're going to use later too. Like all that stuff's over here. If I remember correctly, we use elastic IPs as well. So we're going to click your VPCs. And we see I've got this demo one. Well, I made that earlier, right? I'm going to make a new one right now. That's going to be the one that I made in the lab. That was one of the things that I did last week that I didn't like the way it came out. Is in the video I called them demo, and when I actually did it, I called them the thing they are in the lab. So I tried to flip that around this week, and hopefully it works out all right. So we're going to click Create VPC right here. We're going to create a VPC. We're going to go with the defaults here. We're going to give it a name. It says it's optional, but we need the name, so that's VPC. Oops, my keyboard did something weird. VPC-OPS 345. We're going to give it our own IPv4 CIDR manual input. So that's going to be 10.3.45.0/24. This is a good moment to kind of like review subnetting, right? This is a private IP, right? /24 means the first 3 octets, the first 24 bits, the first 3 octets represent the network. So our mask would be 255.255.255.255, right? And what else does it say in there? No IPv6, leave the rest okay, and click Create VPC. So this is your virtual private cloud, and that might take a minute. Looks like it created. It says successfully created. Note here, this kind of freaked me out the first time. It said Route 53 Resolver DNS firewall rules fail to load rule group. What the hell's going on there? That's fine. We didn't do anything in there, so that's okay. So now that we have our virtual private cloud, that's like our network that we've configured, right? That's basically what that was. Now we're going to configure a subnet in that network. So we're going to click on subnets. Over on the side again. And you can see I've done one here. But I'm going to do a new one. I'm going to click Create Subnet. We're going to give it our VPC, and let's make sure I get the right one here that we just created. Make sure it's not the default, because if you select the default or leave it as the default, it's not going to work, as I learned the hard way. We're going to give it a name. So this is subnet-OPS 345. The availability zone we're going to set to US East 1A, which that's it right there. That's fine. And the CIDR block, we're going to set that to 10.3.45.0/25, not 24. So effectively what we're doing is we're taking that /24 subnet that we started with, and we're splitting it in half. We're borrowing one more bit. We're going to have two smaller subnets. And we'll use the other one for stuff later. That's fine. Under Actions, so this is another thing that that I think threw me off. You got to create subnet first, if I recall correctly. Yeah, we have to create it first. So let's click Create Subnet. It didn't say that in the lab instructions, right? Took me a few minutes to figure that out. So there we go. It's created. Now, we select it. We go to Actions. And we're going to click or select Edit Subnet Settings. Bear with me for a second. And we're going to select Enable Auto Assign Public IPv4 Address. And click Save. There you go. So we're done with our subnet. Now we're going to do our internet gateway next. Remember, you need a gateway to access your VPC. So we go to Internet Gateways along the side here. Again, ignore that one I already created. And we're going to select Create Internet Gateway. It's that big orange button at the top. Tends to be the create things that we want. We're going to call it OPS 345-Internet-Gateway. And we're going to attach it to our VPC, which I think we have to hit Create first. And then go to Actions. Yep, see? Or look, it came up there. You can do that, or you can click the Actions button and select Attach to VPC. Whatever one you want to go, totally fine. So we're going to attach it to our VPC. There's our VPC right there. Click Attach Internet Gateway, and we're good to go there. So we made our gateway. We made our virtual private cloud. We made our gateway. We attached it to the gateway. That's fine. Now we need to go into our route table. So we're going to modify our routing table effectively. Pausing for something to drink. And note, when you're working through this, like check the screenshot in the lab. Yeah, I'm paused. I'm unpaused. I had to make sure because I've done that before. Check the screenshot in the lab and note the underlined things, right? Like there's some stuff in there that you need to watch. So we're going to click Create Route Table. That's going to give us a new thing. Create Route Table. There we go. We're going to call it OPS 345-route-table. We're going to select our VPC. So that's the one you just created. And this has to match or it's not going to work. And we're going to click create. And once that's created, we're going to click edit routes at the bottom here. We see we have our local route. That's fine. And we want to set a route destination. So we'll go to add route. Our destination is going to be the quad 0/0 subnet. So that's everywhere. That's your default route. This is going to allow you to get out to the internet. And we're going to send it to our internet gateway, which doesn't come up there, surprisingly, until you click on it, and there it is. Look at that. So that looks good. When I did this in the my practice run through, I selected the wrong internet gateway. Took me a while to figure out what I'd done. Be careful here. We're going to hit Save Changes. And there we go. We should see we've got our two routes. Our VPC is good there. We haven't done anything with the explicit subnet associations yet. I think we're going to get to that, so just hold on. Yeah, that's our next thing. So after our route table is created, we have to associate it with our subnet. So we're going to go to Actions, Subnet Associations. Select this. We want to associate it with our subnet. And click Save. And there we go. If we go to our subnet associations there, we should see it's associated with our subnet. It's associated with our virtual private cloud, right? It's tied to that. So this is tying everything together that we just created. That's great. So next up, we're doing some stuff kind of like we've already done. It's more practice for the basics, or with the basics, but we're going to do things a little bit differently, as we'll see. So we're going to create a new VM now. We can get out of here. You're probably wondering, well, how the hell do I get out of here? I clicked there before. Yeah, that does not take you out of here. You would think it would. It does. It does not. I could go to EC2 there, because I've already pinned it. But if you go to Services, all services, well, it should show up in Recently Viewed, hopefully. But you can scroll through all services to find it. I think it's down here. Nope. Nope. It's under Compute. There you go. I just kind of guessed to get there. So click on EC2, or if you've pinned it, click the pin. See how much faster that is? Definitely recommend utilizing that for anything you think you're going to need more than once. And now that we're here, we're going to create a new VM. And we're going to call it router. It's not going to do much routing, but it's going to give us some practice with the basics, and it is going to do some stuff. It's going to do some port forwarding stuff that we're going to set up, which is great, which I already talked about, so you know what I'm talking about, right? Before we create a new router, we need to create a new security group and tie it to our VPC, just like we did last lap, because otherwise nothing's getting in. So first off, we're going to go to security groups. We're going to create a new security group. We're going to call it OPS 345 Router SG. We need a description here, so I'm going to call it Security Group for Router Instance. And that's already popped up because I did this before, right? We're going to make sure it's in the right VPC. Which it should be. That should work. And we're going to allow SSH inbound. Don't touch the outbound. We don't want to do anything there. So we're going to add rule. SSH. You did this before, right? The Quad Zero network, again, not great, but it's something. And permit inbound SSH traffic. Or even better, yeah, we'll just stick with that. And then go down to the bottom and click Create Security Group. And we should be fine. So there we go. Our security group's created. Now we're going to create our VM. So we're going to go to Instances. And we're going to create a new instance. And I already created one here. Let me maybe destroy that one so I can do it again. I don't really want to do that. Give me a second. I'm going to pause and figure out what I'm going to do there. Hadn't anticipated this. Alright, there we go. So I renamed the two that I created earlier just so I don't get horribly confused, and I can actually use those names and make this a little bit more confusing. Or less confusing. I don't want to make it more confusing. I want to make this less confusing and nice and like smooth, right? Now you're going to notice all of your instances automatically started up. And if you want to stop them, you don't really need to, but I'm going to anyway. We can go to Instance State, click Stop Instance. Note, Terminate Instance will delete it. So if you mess something up real bad, you could do that, but use that wisely. Stop Instance is what we're going to do to bring them offline, and we see they're stopping. So now I'm going to go ahead and create a new router, or a new VM, or a new instance. I'm going to call it router. And the setup is going to be pretty much identical to the first one we did last lab, in our first lab. So launch instance. We're going to call it router, which I can actually do now because I got rid of that config. We're going to use Amazon Linux. I used the newest kernel, which was selected by default, but well, there you go. And really, if you're going to play around with anything, you probably want free tier eligible, because anything else is going to cost you money. But we're going to learn lots within this course, so just stick with what we're using. We've got our instance type, that's fine. Key pair to log in, right? We still need our key pair. You can use the one from the last lab. So we're going to do that. My first key here, that's the one I'm going to use. If you lost your key pair already, well, hopefully you didn't because you can't get anything from last week, and definitely keep this in a secure location. I'd probably back it up somewhere. This is why having to back up your VM is a good idea, but back it up somewhere secure. You know, on your desktop at home, on a USB flash drive that's on your desk, not moving anywhere, just in case something happens to your drive in your VM, right? I'm actually going to later, when I get a chance sometime, set up an automated backup on my VM folder and have it back up to a virtual hard drive that's attached to my desktop. Anyway, all that aside, we're going to go into our network settings and we're going to change some stuff. So we're going to select an existing security group, and we're going to use the one we created, the router SG. And under advanced network configuration, so you have to get to, I think I had to go to edit to get there. Let's take a look. Yeah, this is not what we want. I think I had to go to edit. Nope. See, the beauty of doing a recording, and I'm doing it a different way this week. I'm not using Teams. I'm going to hit pause again and check my notes and see what I missed, because I know it's something silly. And I'll get there. Hold on. Aha! I think I see what I did wrong. Note what what VPC it's in here. It's in the default one, the 172.31. Well, we don't want that. We want to use the one we just created. Hey, look at that. I think I just broke something else again. Hey, there's our advanced stuff, though. Let's try this. See, that's gonna... It's not gonna like us. What did I do? Time to do some off-camera troubleshooting again. I'll be right back. Alright, so I'm unpausing to show you what I did wrong, and I might have to recreate this. Because this is an easy mistake, and this is exactly what I did before, except it took me, I don't know, like half an hour to figure out what was going wrong. So I'm in my security group that I created. I opened that in a new tab, so I left my instance just as is. Okay? And I opened EC2 in a new tab just by going up to the top. Right-click, open a new tab. Looked at my security group, and when I click this VPC, this is what's wrong. It's going to bring me into my VPC console, and it's going to filter and show me which VPC I actually clicked on. And look at that right there. That's the 172.16.31.00. That's not what we want, right? That's not what we want. I used the default. So, I might need to recreate it. I'm going to mess around a bit more, and I'll unpause in a few minutes, and, well, it'll be a few minutes for you. It might be a couple minutes for me, right? I might have to do some stuff again. But, at least we're getting there. And then, the rest shouldn't be too bad. See you in a few minutes. Alright, so now here's the fix, and let's hope this works. I deleted it. So you just go to security group, select it, go to actions, click delete, and I'm recreating it. And it populated this with the default stuff here, which we don't want to use. And that was our problem. So just delete what's there, and select the VPC you created. And then it's going to be created in your VPC. Handy thing, right? We're going to add our inbound rule again. You've already seen me do this once, but I'm doing it again. To the quad 0, SSH for routers, and we should be good. Port 22 open for everywhere. It's in the correct VPC now. See, it gives you this string here, right? And I was thinking, yeah, that should be in the VPC I just created, right? Wrong. There's a default. It's a little thing. It would be nice if it gave you the name, but it doesn't give you the name. So let's create this again. And then let's go back to our instance. And now, it should work. I might have to redo this instance, so hold on. I'm just going to cancel and do it again. Launch instances. I'm going to pause while I'm doing this again. You don't really want to see me recreate this, so give me a minute. Alright, I fixed it. It took long enough, but I fixed it. I went into edit up here, selected the correct VPC, selected the subnet, select existing security groups, and there it is, after recreating the thing. Finicky. But that's to be expected. I'm going to use my first key, and now I'm actually going to make sure I selected everything appropriately up front, because I did this a couple times in between when I paused last and just now, when you're picking up this 2 seconds later, right? Let's call it router. So now it looks okay. Incidentally, if you choose the wrong security group, you won't be able to access it. That's what I had happen when I did this the last time as my practice run. It was not a good time. Not a good time at all. Yeah. So under Advanced Network Configuration, you just click that drop down here. We're going to set the primary ID, our IP, to 10.3.45.10. So that's obviously not the first IP in the subnet, right? The first four, for some reason, aren't usable, probably because they're reserved for other things that AWS does. So we're just going to start at 10. Problem solved. We don't want a secondary IP. We don't want anything else. We're using the default storage options, so we can click launch. I think we're good. And give that a minute to fire up. So it looks like it's successful. We'll click View All. Where's our router? Look at that. I had to refresh. So we've got a public IP here, right? So we can just copy that. We should be able to SSH into it using EC2 user. So if I just highlight it, here we go. I can copy it right there. So public IPv4 address, there we go. Copy. Pop open our command prompt, and we're going to type SSH -I. Select your key, so that's tilde OPS 345 keys. I can't remember what's there. Jesus. /SSH. There we go. So that's our path. So SSH-I. We could use the tilde. We could not. Like, we're in that directory, right? So we could use a relative instead of relative to home. OPS 345 keys SSH. OPS 345 first key. .pem space EC2 user at, and paste in our IP address. So just right click, paste. Look at that. And hopefully this works. Because if not, I did something wrong. Yay, we're in. Awesome. So here you're going to, and I'm probably going to pause and do this off screen, or maybe not, I don't know. What are we doing for time? We're at 53 minutes. I'm going to pause and do this off screen because it's going to take a little bit of time. But we're going to follow the instructions when I come back. I'll have done this to change the username and the set the host name that we did in Lab 1. And there was even a link to those instructions in Lab 2. So go ahead and do that. Well, I'm going to go ahead and do that. Maybe you're not following along, and that's I don't expect you to follow along with this, right? Your idea is to like watch and see me do it and take some notes. So when you do it, it'll go nice and smooth, and not like spending 20 minutes trying to figure out why you can't SSH in because you put your security group in the wrong thing, right? That's why I'm trying to make it go a bit smoother. See you in a couple minutes. All right, I'm back. And I know I said I was going to resume once I'd done the host name and the default user and stuff that we did in Lab 1. But I thought I'd unpause and just show you something really handy here. I know you've used SU to switch users before, right? But did you know I thought I paused. My bad. So, yeah, you've been sitting here watching me do this for, I don't know, a couple minutes. Oops. Uh, so I did all that. I rebooted. I'm able to get back in. Awesome sauce. Things are good to go. We're going to now continue on with setting up an Elastic IP and associating it with our router. So this is going to be our static public IP for our router. You're going to want to write this one down somewhere because you're going to use it a lot. So to do that, we can go look here under network and security. We can go to Elastic IPs. And we're going to allocate. I'm gonna have to pause for a second because I bound this to my other instance, and I think I'm gonna have to undo that. Oh, maybe not. Associate Elastic IP. There we go. So we click on our instance. I think this might be fine. And we click Associate. It's already been associated, so I need to remove that. I'm gonna pause and figure that out. Be right back. There we go. So I undid what I had done before. So we got my RIP again. It's not associated with anything. So now I should be able to click on Actions, Associate Elastic IP, and select my instance. And it's the only one that's running right now, but we see it's router. And that would have been useful. Click Associate, now it should work. So there we go, and we've got our IP there, and you should probably write this down somewhere. That's our new static IP. Oh, it said name the network interface. So let's do that. We can edit this. I think. Actions. I did it too quick. Manage tags, let's try that. Let's try that. Yeah. Name? I think we're going to be okay. And I'm going to call it router public IP. Save. And there we go. Should be good to go now, I think. Hopefully I did that correctly. And we need to name the network interface router NIC. So when we look at that, it will do that. So if we go here, that's our interface there. This screenshot is not super clear. This is on instance details. Let's go back to our instance. If we click that instance there, maybe we should be okay. There we go. Networking. Interface. see if I can make some changes there. I'm going to pause while I figure this out, because you don't want to watch me do that, right? Oh, I paused and then I figured it out. So if I go to the network interface, I go to action, I go to change description. Aha, look at that. And we're going to call it router-nic. Save. Just make it a little easier to read. And we should be good to go. So now we're going to configure some firewalls. So we're still in here. Let's take a look. Oh yeah, look. Because we added that elastic IP. There's a couple ways to get out of this. Because we changed some networking while we were connected, and that's why we have this problem. The lab mentions there's a key combination you can do to get out of there, and I can't remember what it is offhand. You'd have to scroll through the lab to take a look. I found when I did that didn't work so good. So I'm going to do something I told you not to do, because it was the only other way I could get out of this before. I'm going to close the window, and that should kill my SSH connection. It's not the best idea, or best way of doing things, because like technically it's still sort of open a little bit in the background, and if your VM's been compromised, well then an attacker can get in those like few seconds. But works for now. Works for now. So if we go to our instances, we should now be able to use this IP, our elastic IP, which has been associated with our router. So we copy that, and we're going to do the same thing we did before, just instead of that 3, we're going to use that 53 now. Well, mine's a 53, yours is not, right? And we're going to paste that in, and we're good to go. It did not like it. Give me a minute. Let me see what I did wrong. Alright, I fixed it. After rebooting everything, rebooting my EC2 instance, like shutting down everything and rebooting my PC, I read the error message and did what it said. And I should say yes to this and just get in there. There we go. Yeah. So it said there's this like warning about maybe a man in the middle attack or whatever. Like no, like I changed my network while I was remote accessing a VM in the cloud. I changed its network, and that kicked me out, right? Because it changed the IP. But the SSH key that I generated was associated with the pre-existing IP. So there was it threw an error. Anyway, it says run this command. So I did that. And then I tried to SSH again. And look at that, I'm in again. Awesome. It's the little things. It's the little things. The rest of it should be relatively easy, comparatively. We're going to install IP tables. That's the next thing we're going to do, because it's not in by default with our EC2 Amazon Linux. So I'm back into my router. Everything's good. It says I should update. I'm going to do that at the end of the lab when I'm done, before I shut everything down. I'm going to install IP tables. So sudo yum-y install. In case you're curious, -y will auto assume yes for anything. So I usually do that with updates, and for things that I know I'm going to want to install, like this, right? IP tables -services. And boom, it's installing. We're good. Sudo systemctl start IP tables -services. Actually, I think we just need IP tables. Let's see if that gives us what we want. Should. Yay, it did. And we're going to enable that to start on boot, because we want that to start automatically on boot. Without that, I mean, it's going to do our port forwarding, right? So we're going to enable that to start on boot. enable. And looking to see how long our thing is up to now. So IP tables is good to go. But we don't have much to do with it, right? We're going to port forward stuff to a VM that doesn't exist. So we're going to set up a VM to do that. We're going to call it WW, not www. It's just a temporary one for this lab. We're going to delete it later, and we're going to recreate it. Next week, we're actually going to make a web server, and we're going to use our port forwarding rules that we're setting up here to forward SSH traffic from our router to our web server that we're going to set up next week without directly SSHing into it. Isn't that awesome? So let's go do that. We're going to go set up a temporary VM. I'm going to call it www. And I'm just going to pause while I do that, because you don't need to see me do that, right? We've set up a couple of these. So I'll be with you in a couple minutes when I've done that, because then your video is not super long. I know I said I was going to do this all off camera, but make sure you select, when you're doing this, the correct VPC and everything. So go and edit that stuff with your new instance, because again, that default's going to throw in there, and it's gonna drive you crazy troubleshooting stuff for a while. So, better safe than sorry. Okay, found another thing. So when we're doing the security group, we're not going to associate with an existing security group. We're going to create a new one, and we're going to name it OPS 345. Oops, I'm not in the window. Router SG, or WWSG, and description: allow SSH from router SG only. So that's a big difference, right? We're making it a little bit more secure. So our source, I think we can go to custom here. Scroll down. And then if we click source, we should see. Oh, look at that. We scroll down, security groups, router SG. So that makes it a lot more secure, right? We're not allowing SSH from anywhere. We're just allowing it from router security group. I'm going to pause and continue on again. Okay, so we've got it up. Now we've got our instance up, right? So if we go back to instances, we see it launched. And in fact, I'm going to refresh here. www, yeah, so it's still creating it. It's not up yet. That's okay. There, now it's running. Awesome. So if we try to SSH into that, even though it's got a public IP, that's going to fail. And that's fine. We're going to set up some port forwarding rules on the firewall for our router to forward incoming SSH connections to that IP. So that's a handy thing. And I mentioned this one when we did the lecture. We're going to modify the pre-routing and post-routing IP tables rules. So let's go back to our VM. We're in here now. We're going to add sudo IP tables -t nat -a. So we're going to append it to our pre-routing table -p TCP. That's going to go to destination port 2211 -j dnat -2 10.3.45.11 colon, don't forget the colon here, 22. And it didn't like that. Oh, because I didn't capitalize pre-routing. Told you, I'm going to make mistakes. You've seen a bunch of them in this recording, right? I've paused and fixed things, and that may or may not happen depending on the complexity of the lab. Some of the stuff we're doing here is, like, it's simple, but it's not, right? Even for me. There we go. So I took that one. Sudo IP tables. And if you're curious about these, they're all in the screenshot in the lab. So we're good there. -D. Forward. Whoops. It's all caps. Space 1. Sudo. Whoops. That's not going to work. You gotta spell sudo right. IP tables -T nat -A post routing. Whoops, and that's going to yell at me because that's not an uppercase A. -O, so we're sending it to an interface. F 0 -J for jump. Masquerade. Queurade. There we go. And then if we do sudo IP tables -L -N -T. Whoops. Nat. There we go. We should see our stuff as it looks like in the lab screenshot. And sudo IP tables -L -N. We're good to go. So, one more thing to do. If this was a CentOS install, that would have been enough. But Amazon Linux has routing disabled by default. You have to enable it. So we go into systemctl. So vi etc sysctl .conf and go to insert mode. We're going to go to bottom. And we're going to add a line. Enter. Get rid of that comment that it auto puts, because we don't want that. net.ipv4.ip_forward equals 1. If you don't get rid of that comment, this isn't going to work. Not going to get very far. Save that. And then sudo sysctl-p. There we go. And we're going to check and see if it worked. We're going to sudo cat proc sys net ipv4 ip_forward. And it shows a 1, so we're good. Next thing we're going to do, last thing we're going to do actually, is we're going to add that port 2211 to our router security group. So let's go to our security groups. And if you don't do this, it's never going to get there. So this one here, I think we should be able to just click on that. So inbound rules. I think it's inbound rules. It should be inbound rules. So we're going to add custom TCP. We're going to stick our port in there, so that's 2211. And that's going to go to our router security group. And SSH for our SSH port forwarding. Save that. And if everything works properly, we should be able to, just gotta type exit there. We're going to want to go back in there later and run some updates. I'm going to run some updates on both of these once I'm done. We're going to go look at our router. It should actually work, I think, just fine. Nope. Give me a second. This is really small. Alright, so I'm seeing what I did wrong. We're going to exit out of this one again. Whoops. So we're going to type a slightly different command here. SSH-I. We're going to select our key. Keys. SSH. OPS. First key. I'm just using tab to autocomplete. And it's going to be EC2-user at, we need our public IP, which should be the same as we used here. I think I could pull this out of AWS just like Andrew did in the screenshot. But we're going to try this, and if it fails horribly, which it could, we're going to specify the port, 2211. And should hopefully be in. Go to our instances. Since we're waiting for that. And clearly I've messed something up. So let's, because I know I can get in there. Let's do an iptables-l and let's take a look. Oops. I think I put that in the wrong order. So that looks fine. Dot 3.45.11. Let's check on that one. Yeah, that looks fine. I messed something up because this worked in my demo. Gotta check my notes. But, yeah. It's the little things. We're gonna redo it next week anyway. Yeah, it's really, really quite strange. I'm not going to waste your time with fiddling with this. I'm going to fiddle with it, offline and get it fixed up for your lab. That's it for the lab. Make sure you go through the bottom, look at the bottom of the lab, and submit your different screenshots as defined there. And, yeah, I will see you in the lab this week. So take care, be safe, have a good week. Sorry this didn't work, this last little bit. And when I figure out what it is, well, I'll tell you in the lab. Like, things don't always go according to plan, right? Take care, be safe, bye for now.